Okay, geotrig, this is lesson 17. It's about proofs. Actually, it's about similarity proofs. So it's not congruency. We're going to talk about similarity today. But along the idea here is we use Pythagorean's theorem a lot. So let's actually do a couple proofs here that lay the foundation of why it works. And so what they do is they start off with a very large right triangle. I guess it's not stated, but this would be a very large right triangle there. You can see it's upside down, laying on top of its hypotenuse. We're going to call C. Can you guys at least see the fact that C is the hypotenuse, the very large side here. A is a leg, B is a leg. We know Pythagorean's theorem is A squared plus B squared equals C squared. Okay, here's a really cool thing. We've seen triangles like this before, and we actually had to prove certain sides had a certain ratio or solve for a particular side. You guys remember this? We showed that they were similar first, and then we could say, hey, if they're similar, they have a ratio between them that it doesn't change, and la-di-da-di-da. We're going to use that fact here. So if I was to basically cut that triangle in half, or not half, I guess you say, into two other right triangles, one on each side, you guys would get these. Give or take, right? They're not perfectly the same size. But you guys see that that forms, if I sandwich these two together, I'll form the very large one. So let's label our sides. What's this side? That's B. What about this side? That's A. What's this side? And? X. So if I know those sides, now if I can prove that they are similar to each other, and we've done that a couple times already, would you guys agree that, wait a minute, on the very large triangle, we have a single tick mark angle right here? Corresponds to this angle? So would you guys agree that that would be a single tick mark? Yeah. Look all the way to the other side in the left hand. A double angle, which would be here. Interesting. Oh, wait. We know, according to this big triangle and a very large triangle, that we have a common angle of a double here, a right angle, so therefore this angle and that angle are the same. Two angles implies all three. Okay, hold on. Let's do it again. Each one shares a double tick marked angle, right? They also both share, we're talking about the very large one here, have a right angle. So that means this angle here and the angle up here have to be the same, and that's a single tick mark. All three angles are the same, therefore they are similar. Can I do the same thing with the smaller triangle? Yeah. They both share a 90, and they both share a single tick mark. So therefore, the one way up top here is a double. That proves not only do the two individual triangles be similar to the very large one, it also shows that the two smaller triangles are similar to each other. And I think we have stated this in one of our other videos, another outline before. So now all we have to do is set the triangles together in their corresponding parts. Let's try this once with this idea of the medium triangle to the large triangle. B. So let's go medium to large. B, which is the hypotenuse of this one, is the hypotenuse of the large one is C. So B is to C, as I go back to those medium one, Y is to, now where's Y? Y opens from the single tick mark. The single tick mark is, oh, B. Interesting.
C equals Y.
Not C equals Y. Yeah, wait. So wait. B squared equals CY? If I cross multiply those? To equal anything I know. I mean, I got a B squared. Maybe that'll come in handy. But that's interesting. Don't you think? What if I did the, I'll change colors. What if I did the small to the large? Side A. A is opposite the 90. Opposite 90 of the large is the, oh, C again. Interesting. X is the other small one that we know. X is open of the double. And the double opens to A. Whoa, what would that give us if we cross multiplied? A squared equals CX. So wait. Happens to be that I've got a B squared equals CY, and I have an A squared equals CX. Could I add those two results together? Could I say A squared plus B squared? But if I did that, what would the other side have to equal? CY plus CX? Just by adding their pieces together? Is everybody okay with this? Can anybody see where we're going with this? What do you think my next step is? What's common on the right-hand side? C. Can I take the C out? So A squared plus B squared equals, not divide, but I'm going to factor. And if I factor out a C, I get Y plus X. Go back to your original drawing. What's Y plus X? It's C. Whoa. Y plus X is the whole distance for C. So can I use substitution and take Y plus X out and put a C in, which is C times C, which is? And so A squared plus B squared equals C squared, which is C squared. So, therefore, A squared plus B squared equals C squared, and that is Pythagoras' theorem. Booyah. Pretty cool stuff, huh? Okay, lesson 17, day 1. We'll put this as day 1. Page 131, 9 through 14. Have a fantastic night.